This is section 8.5, part A, dot and cross products of vectors in space. Your I can statements for this section: I can find dot products of an angle between vectors in space, and I can find cross products of vectors in space, and use cross products to find area and volume. The dot product in 2 dimensions and 3 dimensions is very similar. The only difference between 3 dimensions is you do need to add that third term. So a dot b is going to be a sub 1 times b sub 1 plus a sub 2 times b sub 2 plus a sub 3 times b sub 3. Again, if a dot b is equal to 0, it is still going to be orthogonal. This will determine the magnitude or the length of this new vector. To find the direction or the angle of this new measure, new vector, you're going to do the cosine of theta is equal to a dot b over the magnitude of a times the magnitude of b, again just like you did in 2 dimensions. So the first thing we're going to do is do the dot product. Remember, your first vector is a1, a2, and a3. The second vector is b1, b2, and b3. The dot product says a sub 1 times b sub 1 plus a sub 2 times b sub 2 plus a sub 3 times b sub 3. So we're going to do negative 7 times 5 plus 3 times 17 plus negative 3 times 5 . So we're going to have negative 35, 51, and negative 15. And all together, if we add that together, we're going to get a value of 1. Since this is not 0, this is not orthogonal. On the next one, this is our a sub 1, a sub 2, a sub 3, b sub 1, b sub 2, and b sub 3. So we're going to do 3 times 4. Plus negative 3 times 7 plus 3 times 3. 3 times 4 gives us 12. Negative 3 times 7 gives us a negative 21. And 3 times 3 gives us 9. 12 plus 9 is 21. 21 and a negative 21 gives us 0. So this one is orthogonal. To find the angle theta between the 2 vectors, we're going to use the cosine of theta is equal to a dot b over the magnitude of a times the magnitude of b. So we're going to start by finding your a dot b first. So we're going to do 3 times negative 4 plus 2 times 3 plus negative 1 times negative 2. This is going to give us negative 12, 6, and 2. 2 plus 6 gives us 8. 8 plus negative 12 gives us a negative 4. So we know our a dot b is negative 4. Now we're going to find the magnitude of a. In this case, our a is our vector u. When you find magnitude, it's the square root of your first term squared plus your second term squared plus your third term squared. 3 squared is 9. 2 squared is 4. Negative 1 squared is 1. So we know the magnitude of a is going to equal radical 14. To find the magnitude of b, we're going to do negative 4 squared, 3 squared, and negative 2 squared. Negative 4 squared gives us 16. 3 squared is 9. Negative 2 squared is 4. 16 plus 9 is 25. Plus 4 gives us 29. Now remember, when you have a radical times a radical, you can multiply the values that are underneath the radical. And 14 times 29 is going to give us radical 406. To get the theta by itself, we do need to use the inverse cosine to take that cosine to the other side. Now make sure when you put this in your calculator, you put it in as division and not a fraction. Calculator does not like doing inverse cosines when there's fractions and radicals involved together. And we're going to get theta is approximately 101.5 degrees. Another important product involving vectors in space is the cross product. Unlike the dot product, the cross product of two vectors A and B in space, denoted A cross B, is a vector, not a scalar. So when we get done here, we're going to end up with a vector, not just a length. The vector A cross B is perpendicular to the plane that contains vectors A and B. So if we look at this picture, vectors A and B are both on that plane that's on the bottom. The vector of A cross B will be the vector that is perpendicular to that plane. Now, if we have vector A as a sub 1 times vector I plus a sub 2 times vector j plus a sub 3 times vector k, and vector B is b sub 1 times vector I plus b sub 2 times vector j plus b sub 3 times vector k, then the cross product will look like this. Another way to set this up is to think of finding the determinants of your little vector. So we're going to break this up. With vector I, you're going to ignore that column. So we're just going to find the determinant of the first one. So we're going to do the determinant of a sub 2, a sub 3, b sub 2, b sub 3, and we're going to times that by vector I. Minus, when we look at vector j, we're going to exclude that part, so we're just going to use the other parts. So we're going to find the determinant of a sub 1, a sub 3, b sub 1, b sub 3, and we're going to multiply that by vector j, plus, when we use vector k, we will ignore the stuff that's in that column. So we'll do a sub 1, a sub 2, b sub 1, b sub 2 times vector k. Now this is the same thing I've written out here, because remember when you do the determinant, it's the one that's in position. This is A, B, C, and D. And remember when you find the determinant, you do A times D minus C times B. So if we look, they're doing A sub 2, which is our A, times B sub 3, which is our D, minus A sub 3 times B sub 2. So those are our B and our C. So we need to find the cross products of vector u and vector v. The first thing we're going to do is we're going to write it so it is in this form. We write vector u first, and then we write vector v. Now when we write this out, it's going to be the determinant of one vector times I, then the determinant of the next vector times j, and the determinant of the next one times k. Remember, when you're multiplying by I, you ignore what is in that column. So we're going to do the determinant of, if we ignore I, we're going to be left with negative 2, 1, 3, and 1, and we're going to multiply that by vector I. Minus, we're going to do j next, so we're going to ignore everything that's in the same column as j. So we're going to have 3, 1, negative 3, and 1, and that's multiplied by vector j. Plus, we're looking at k, so we're going to ignore everything in that column. So we're going to have 3, negative 2, negative 3, and 3 times vector k. Now remember, when you are finding the determinant, we do a times d minus c times b. So if we come down here, we're going to have negative 2 times 1 minus 3 times 1, and all of this is going to be times by vector I. On the next one, we'll have 3 times 1 minus negative 3 times 1, and then it'll all be times vector j, plus 3 times 3 minus negative 3 times negative 2, all times vector k. Negative 2 times 1 is negative 2, negative 3 times 1 is negative 3. Negative 2 and negative 3 gives us negative 5i. 3 times 1 is 3. Negative 3 gives us positive 3 times 1 is 3. And 3 plus 3 gives us 6. But we do have this negative sign out front, so it's going to be negative 6j. 3 plus 3 gives us 9. Negative 3 times negative 2 gives us 6, but we have the minus between them, so 9 minus 6 gives us 3, so plus 3k. So the cross product can be written as negative 5, negative 6, and negative 3. Or you can write it as negative 5i minus 6j plus 3k.